Sup everybody, how's it going? Right guys, okay, so I'm going to get straight on with the lesson. Today is an introduction to GCSE Organics. It's nice to see I've got 11 people watching, which is amazing. So I'm gonna get straight on with my lesson today, folks. So share my screen, and then I'm gonna switch over to my clip cam. I think that's a good idea. So I'm gonna get straight into my lesson. It's so low. Share my screen. There we go. There we go. Got rid of that. I'll pop out the chat. Pop out chat. There we go. And then I can close the YouTube screen altogether. There we go. It's trying to load it now. It's gonna be interesting. This. Check out my helmet. Ooh, Boba Fett. Toba Fett. We got 4 people watching now. Okay, right, guys, let's crack on with today's lesson. So here they are. Here's the learning objectives. I'm going to switch my tablet into tablet mode. I'll also put my little fan on because my laptop is already overheating, which is amazing. Okay, so you actually cover this part of organic chemistry. You cover it in year 9. So this just happens to be the way that BSKL works. But this is a really nice introduction to organic chemistry. And I do want to make a very clear point here that there's a difference between organic chemistry and inorganic chemistry, and that you've been dealing majority so far with inorganic chemistry. And although you've come across certain parts and little kind of tasters of organics, this is usually relatively new to people. So just to quickly mention, and I'll do this first of all, I'll leave those up there because I know that Jack often likes to copy them down. So it's an introduction to organic chemistry, and it's just nice for me to mention that chemistry is kind of split into 2 areas. We've got inorganic chemistry, inorganic, and we've got organic. Now, just to explain the differences between these, so organic chemistry is based on carbon, is based on the element carbon, based on the element carbon and its compounds, carbon and its compounds. Whereas inorganic chemistry, and this does actually, and its compounds, inorganic chemistry is based on things like salts and gases that don't contain carbon. Now, there is a little bit of, there are a couple of idiosyncrasies in this, which I'll explain now. So inorganic chemistry is like acids and alkalis, acid bases, it's salts, which don't contain, salts. There are some idiosyncrasies, as I mentioned earlier. So, for example, I'm just going to give you some examples of this. So, in organics, this is sodium carbonate. Now, although that does include carbon, it's not considered organic. This is an ionic salt. So, this is, you name this as sodium carbonate, but this is inorganic. Even though it contains carbon, it's not really, it's not an organic compound because it's not covalent. There is another example, which I do need to mention here, which is carbon dioxide. Carbon dioxide is also considered inorganic. People often ask me why it's considered organic, not organic, considering it's carbon-based and covalent. The reason being is carbon dioxide can't grow in size. You can't get large, you can't get bigger compounds with it. You can't end up with like C4O5. It's not something you can do. So even carbon dioxide is considered inorganic. The organic compounds are things like CH4. Now, the point I'm trying to make here is that the naming is different. Yeah, in organic chemistry, this is called methane. Yeah, and that is following what's called the IUPAC nomenclature. Now, what that actually stands for people of interest, for people who are interested, this stands for the International Union of Pure and Applied Chemistry. it's actually chemists technically, International Union of Pure and Applied Chemistry. And they're called the IUPAC. This is actually a group of about 6 or 7 guys. Sorry, girls, there are no girls on the panel for these guys. They're all around about the 70s, 80s mark. They're really old. A couple of them died recently and they got replaced by younger ones who are like 71. Really funny. But the IUPAC is just a group of people who came up with the naming system. And the word nomenclature literally translates to naming system. The word nomenclature is a naming system. And they came up with this system. They said, we need a way to be able to name organic compounds and be able to draw organic compounds from their names. Because the reason being was, in the past, a bit of history. Yeah, a great example. This is just a bit of a history lesson now. So a bit of history behind this. A great example is the compound formaldehyde. Formaldehyde. You guys might recognize formaldehyde. It's the stuff that you put dead organisms in to preserve them. Now, formaldehyde, if you don't know what the word formal or formyl means, it's very difficult to draw. So what they then did is, this is the historical name. This is the old name. And the IUPAC then said, well, hang on a minute. We need to be able to draw this. And what this is actually is methanal. Methanal. This is the IUPAC name. Old name versus the IUPAC. And I can now draw this. Based on my understanding of the naming system, I can now translate this into a structure which I can then draw because I know the rules of the naming system. This one would be very difficult to draw if you didn't know the name. Another great example of this is toluene. So otherwise known as TNT. Now this is an old name. And the trinitro is useful because tri in organic chemistry means 3. We'll get to that in a minute. Nitro gives me the nitro group, but then toluene is the old name. This here is the old name for TNT, old name. The new name, however, so that's very difficult to draw if you don't know what toluene is. So what IUPAC did was to be able to put that into a more sensical name, which is, I've got to really think about this now. It becomes 2,4,6 trinitro methyl benzene. That's now the new name of TNT. Yeah, this is now the IUPAC. And I can now draw this IUPAC because I understand their naming system. So not only am I getting numbers that tells me locations for people, you didn't get that in TNT. Yeah, there were no numbers anywhere. Now I've got numbers. Technically, by the way, you can also include a 1 here if you like as well. They don't mind that. You wouldn't bother, but you can. I'm tempted to actually put it in just to make it easier for me to show you how the naming is built. I'll actually add that in. I prefer it. 1-methyl benzene. So I can now build that based on my understanding of the name. So benzene looks like this. This is the picture of benzene. I've got a 1-methyl branch, which is up here, which is a CH3 group. And then on carbon number 2, I've got a nitro group. On carbon number 4, I have a nitro group. And on carbon number 6, 2, 3, 4, 5, yeah, 6, I've also got a nitro group. So I can now translate out of IUPAC, but in the past, if you didn't know what toluene was, you were unable to draw what TNT was. So the IUPAC system is a really lovely method, to a lovely set of rules that allow you to build things from names. Also the reverse, to take a structure and be able to then therefore name it. So the naming system is nice to mention at this point. So just a quick little game here, which is just to mention the difference between organics and inorganics. So if I go for sodium chloride, I know that that there is inorganic. So I can put underneath this is inorganic, and I will name it based on my inorganic naming system, which is sodium. The metal always goes first and the name never changes, and the chlorine becomes chloride. And that's the only real change. That is called inorganic naming. Whereas if you then have something like, I'll draw this out. So if I then have something like this guy, I can now say, right, now I'm going to run my IUPAC rules in organic naming, and now I've got 2 carbons in this. Now 2 carbons in this system is called eth. I have a carbon-carbon single bond, which means it's an ane, and I'm done because there are only H's attached. The H's don't get any names, and it just becomes ethane. So the method of naming is very different for inorganic versus organic. Something to bear in mind. Okay, so now what I'm going to do is I'm going to do my first learning objective to be able to, I've got the Destroyer 205 plays. Hi. Hi, nice to see you. I'm going to call you, I'm going to call you Des. Des. I could call you the Destroyer, but I just don't, I think it's a bit much. I'm just going to call you Des. Sup, Des? Thanks for coming along. So, I will teach you this naming system, by the way, guys, as we go along, so don't worry about that. Okay, so what I want to now do is introduce you to the organic families for GCSE. Now, I'm actually going to introduce you to 10 families, even though only 6 of them are needed at GCSE. It might actually be more than that. I'm going to introduce you to all the 10 AS families in organic chemistry. I will highlight the ones that are at GCSE, though, and the extension ones for A-level. But it's just nice for me to do this. If I'm going to do it, I'm going to do it properly. Yeah. So so we can now do subheading, and that's going to be organic families. Organic families. Now, I do want to point out something here, folks, that the word families in chemistry isn't really a thing. What I actually have to do is I've got to translate this into the real chemistry word of organic homologous series. This is actually the posh word for family. Now, this comes with a series of points that I need to mention at this point. So family means homologous series means family. Now, what that means is that if you are in a homologous series, you're in the same family. So we need to pick up some points for this. So what we need to do is we need to actually kind of, I want to say define it. It's not quite defining it, but homologous series, I'm going to do nota bene on this one. So they have certain properties. So these are substances in the same family, the same homologous series. Yes? So properties. Number 1, they have molecules with the same functional group. Now, I'll explain that. Same functional group. For example, yeah, e.g. So, for example, I could have ethene. This is an alkene. And I will highlight the functional group. The word functional group. The word functional group means structure that gives chemical properties. So in this case, I have got ethene. This is eth, and I'm going to change my color, ethene. And the point of this is that this is the bit that means it's an alkene. It has a carbon-carbon double bond. Yep. So let's look at another member of the same homologous series, the same family. That would be something like this guy. So I'm going to put it out to the class if they want to have a go. It's always nice to really impress me, Year 10. And Des, can somebody please name me this compound? Somebody name me this. So it's in the same family. The reason being is it contains a carbon-carbon double bond. So it's still the same family, same homologous series. Yep, because they both contain the double bonds. The question is, can anybody in the class butane? Ian, be careful. You've not realized the ending and the similarity, Ian. Yeah, it's not butane. Ethanoic acid, Lauren, you've gone mad. You've gone completely mad, completely different family. I've actually had two different homologous series there. What he said. It's not butane. It's butene. It's butene. Not ane, but ene. Because the ene tells me that it has a double bond. Let's look at the two people that were named. This is comparison-wise versus my answers on the classroom. So Ian, by the way, well done, Ian, for remembering bute. Yeah, this is actually butane. Look at the difference. So butane doesn't contain a double bond. Yeah, they're all carbon-carbon single bonds. This one here is butane. I'm going to show you what Lauren said, butene. I'm not sure. Owen, well done. It's butene. Yeah, here's what Lauren said. Lauren went completely crazy. Yeah, she said ethanoic acid. This is ethanoic acid. This is a completely different family. So this is butane, and it comes from the alkane homologous series family, the alkane family. This one is ethanoic acid, and this one is part of the carboxylic acid homologous series or family. Yeah. So it's nice to show the difference between these. It's also like we'll be learning the IPU. I'm not expecting you guys to know this already, and if you do, that's awesome. That means you're ahead of the curve. That's great. My whole point of my lessons in this topic are to me to be able to get you to the point where you can name anything that I give you. So homologous series properties, molecules with multiple molecules with the same functional group. Now, and this now comes up as the second bullet point for this. Structures that give chemical properties. So these will be molecules with similar chemical properties. Molecules with similar chemical properties. And the reason for that is because they have the same functional group. Properties. There we go. They have one more property as well. Same general formula. They've got two, sorry. Same general formula. I'll explain that later. See later notes. And the last one is their physical properties. Their physical properties. Physical properties. Physical properties increase in a trend. With chain length. Now, can I just point out, I've given you an awful lot of information there. So what I need to explain now is each one of these bullet points. This is so helpful. Oh, you're very welcome, Des. So now the thing is, it's really easy for a chemistry teacher. Now, might be something that Des has come across. It's very easy for a chemistry teacher to give all these words and then explain nothing about it. So it's nice for me to explain each one of these things. So the molecules with the same functional group, we've covered that. These two molecules have the same functional group. The next thing is that these structures, this structure here, will convey the same chemical structures between these two. So for example, just to give an example of this, I'll do this in blue, e.g., yeah, both ethene and butene will decolorize bromine water. This is actually the chemical test for the double bond, bromine water. I can actually explain this a little bit further, just to explain this to you guys. So decolorizing bromine water. So if you have a molecule with a carbon-carbon double bond, so I'm just going to do ethene now. Let's just do ethene to make this easier, and then I'll do the bromine next to it. So we've got ethene and then bromine. Now we know that bromine is orange. Bromine water is orange. Now the reason for, so it's just nice to mention this, then by the way, it's nice to give a state symbol as well, aqueous, and this is orange. Whoops, there we go, orange. When ethene is put in the presence of this, the double bond will reach out and steal a bromine, that bromine hops off, yeah, and what we now get is this is now what's called an A-level mechanism. The double bond breaks and the bromine attaches to here. You don't need to know this for GCSE, but it's nice to see it. This is an introduction to A-level. Yeah, this is something you're going to be able to do at AS. And that hops on there, and the final product, so the bromine will actually destroy the double bond, and the bromine atoms will go across it. So I get one bromine on one of the carbon atoms and one on the other. And this compound here is colorless. And we have destroyed the orange bromine. The orange bromine was there, and now it's been destroyed, and it's now produced a colorless compound at the end. By the way, to name this is 1,2-di, di means two in chemistry, dibromoethane, no longer an ene. Yeah, it's now become an ane. That, by the way, I'm not expecting you guys to know this yet, but you will by the end of this topic. Yeah, you guys will be able to do that at the end of this series. Yeah, so butene does the same thing. Let's look at why they've got similar chemical properties. So here is butene. By the way, this is actually but-1-ene. So you know, that's again, it's A-level, but I'll be adding that in at GCSE anyway, because it's good. It's good. You can use it today at GCSE, and it's actually a better answer. Easier for me to teach you this properly at the beginning than to reteach it at A-level. So why does this have similar chemical properties? Because the orange bromine, once again, the orange aqueous bromine will react with the double bond. The double bond will react with it. That breaks off. The product I get, the double bond is now broken. The double bond is now broken. One of the bromines is now attached here, and then the second one will be then picked up in the second step. And at the end of it, I'll show all my H's as well. I'll be good today. I should be good all the way through. Yeah, there we go. So they have similar chemical properties. And at the end of it, there is no more double bond, and there is no more orange bromine either. So the bromine's been destroyed, it's joined on to the alkene, and I now have 1,2-dibromobutane. So this one is now colorless. So we started off with orange bromine water. This is orange Br2 aqueous, which means bromine water. And then at the end of it, it's been destroyed. So they have similar chemical properties. They will both decolorize orange bromine water. The next thing is general formula. So a general formula is the idea that you can do, and I'll try to explain this as best I can. We'll be coming across lots of these. So we've been looking at alkenes. So ethene, so C2H4, the general formula for this alkene would be CnH2n. So the number of carbons is 2, in this case, C2, and the H's are then doubled, 4. Yeah, so this is called the general formula, general form, and this is the molecular form. And I just want to show you the similarity, because if we then do butene, what we realize is, this is just explaining why the general formulas are the same. Still haven't even introduced you to any of the other families yet, which is hilarious. Yeah, so this one is C4H1, 2, 3, 4, 5, 6, 7, 8. Oh yeah, look at that. It's CnH2n. It's the same general formula. Yeah, because it's simply, the H's are simply double the number of carbons. Super handy. So the same general formula. The next one is their physical properties increase with a trend. So just so you know, what this means is if I have ethene with 2 carbons, I ought to actually look up some values here and actually show you this. Here is ethene, here is propene. Here is propene, got to count my hydrogens very carefully with the alkenes. Yeah, there's propene, here is butene. And if I was to ask the classroom, let's see who knows this, which one of these 3 will have the highest boiling point? So physical properties include melting and boiling point, viscosity, yeah, all those kind of things. So we've got ethene here. This is ethene. This is propene. Notice the similarity in the name, same homologous series. This is butene, same homologous series. It's still an alkene. Which one's going to have the highest boiling point out of those 3, please? This is where I now need to, I hate like giving fake numbers. It's not something I enjoy doing. So if I do ethene boiling point, it's minus 104. Let's go for that, minus 104 degrees Celsius. Wow, very low. It's maybe a gas at room temperature. Holy moly, it will be. Let's go for the next one. No one's posted on the chat yet. A bit disappointed. Propene. Let's go for this one. Butene has the highest boiling point. Thank you very much, Gayatri. Propene, minus 48. Minus 48. Thank you, Gayatri. You're a star. Well done. Butene will indeed have the highest boiling point. Let's go for the last one. So butene, let's check it out. Butene, minus 6. So you can see it's increasing in a trend. If I was to plot a graph of this, minus 104, yeah, they're going up in a nice steady trend. This will be C2, this would be C3. This is, as the carbon length increases, this is going to be the boiling point in degrees Celsius. Yeah, you can see that it's following a nice trend. Well done, Julius. Absolutely spot on. So the longer the chain, the higher the boiling point. And that's what it means by their physical properties increase in a trend. So can I just point out, guys, I really need you to learn this. This is a really important set of things, this properties of the homologous series. Yeah, please learn that little group there. It's really important. Yeah, they do love to ask at a GCSE. Okay, let's introduce you. I've got 20 minutes. Let's introduce you to your families, folks. Okay, so new subtitle. New subtitle is Homologous family. This is just means families, remember. Homologous series to learn. So, brackets. The 10 families. Right, now just to point out, at A level, there are 10, at AS level, there are 10 families to learn. At GCSE, I believe there are 6, but we'll see when I go through them. So, family number 1, I'm going to start off with IGCSE, or just GCSE actually, because it counts for all of them. GCSE, so we have family number 1, the alkane homologous series, the alkanes. Next, number 2, is the alkenes. We've seen both today very briefly. So we've got alkanes, we've got alkenes. Number 3, we need alcohols. The alcohol homologous series or family, the alcohol family. Everyone loves the alcohol family. Number 4, we need the carboxylic acid family. Can I just point out that was one that Lauren mentioned earlier, which was nice. So the carboxylic acid homologous series. Number 5, haloalkane family. This is still GCSE. Haloalkane family. We saw one of those today with bromoethane, or 1,2-dibromoethane actually, is what we saw, but that was a haloalkane. Number 6, got to be careful now. Esters, annoyingly at GCSE, esters. Now that, I believe is the end of the GCSE list. Alkanes, no, we've got polymers too. I need to add in number 7 there, but it's not a family. It's a bit of an odd thing there. I will add it in there. So polymers, I'm actually going to put it off to one side. Yeah, number 7, but it's not really 7. It's linked to the alkenes. Alkenes, I'm gonna do a little 2.5 here of polymers. Polyalkenes. It's not exactly a family, but it kind of is. So I'm going to add that in there as 2.5. Now this brings us to the end of GCSE, I believe. Alcohols, carboxylic acids, esters. Yeah, that brings us to the end of GCSE. However, I am going to extend this and give you the rest of them for A level. So number 7 is aldehydes. Aldehydes. You do not need to know these if you're not considering doing A-level chemistry. Don't worry about it. Yeah, aldehydes. Ketones. Ketones. Number 9. Amines. Nitriles. Are there any I have forgotten? The annoying thing is I think I have forgotten one because esters technically are A2. The next you pick up esters at GCSE and then you don't revisit them until you get to A2. Very strange. Which means I'm missing a family. Think, Mr. Duncan, think. Oh, cyclos. You need that for GCSE. So alkenes, I'm going to add that in because technically you see the ester doesn't actually in the AS family because it's in the GCSE one. But I will also add this in, and you do need this for GCSE. So I'm going to add this in. Annoyingly, it goes on the alkene section as well, which is very irritating. 2.7, which is cycloalkanes. I could just put cyclo ... Cyclos. There's no actual S, by the way. It's just cyclo. Cyclo ... Right, those are all your families. Yeah. Now, just to explain, as I said, it's a bit odd this, and at this point, people are always like, oh, that's really confusing because they're all over the place. And I'm like, I understand this. So just to explain, this one here, the esters is not in the AS family list because you don't need it until A2. Yeah, so that's not usually in the list. So these cyclos are usually number 6. The polyalkenes, because they're an extension of the alkene family, it tends to go on separately. I know it's a bit awkward, guys, but unfortunately, it takes practice. After a while, this just becomes like routine. I promise you, it gets easier. Okay, so now that we've seen what families we've got to learn, what's important to do is really, so use IUPAC to name organics and drawing. So we're not going to get to that point today. So what I now want to do is I now want to focus on these families because I want to show you what each of these looks like. So, okay, so what I'm going to do is I'm going to show you one of each of these guys and just explain to you which bits are important. So, is that what I want to do? Yeah, probably. Oh, I don't know. It's an awful lot of information to give you. I don't see there's any value in it. Okay, so this is just going to be, I'm not going to do that now. I've changed my mind. I'm going to go into the naming, IUPAC. So what we're going to do is I'm now going to go through these families one by one in my lessons. So technically there are going to be, in this sequence, there's going to be 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to do all of these in my lesson. And then these are ones I'm going to do in the sequence. And then I'm also going to do some extension lessons where I cover the AS ones as well. Okay, so subtitle, IUPAC. Nomenclature. Organic naming. So this is how we name organics. I need to talk you through this process. Now, can I just make something very clear here? The way I teach this is that I teach this in stages. This is not something you just dump on people to use. Yeah, what you need to do is I teach you the basic set of rules, and then I will add another rule to it. Now, some people don't like that. Some people like to have all the rules all at the beginning. But if I do that, it actually doesn't work as well. I've tried it. Trust me, it doesn't work out well. It's far better for me to do this in stages. So don't be annoyed if I then go, oh, by the way, here's the next rule. Don't be annoyed at this. This is not something you can just give straight off the bat. So you have to go through this slowly. So what we're going to do is we're going to start off with our number one family. We're going to start off with alkanes. Okay, so what's special about alkanes? Only contain carbon, yes, you have to write it twice, single bonds. You have to write carbon. I keep having students make this mistake. This bit is really important. Yeah, only contains carbon, single bonds. So let's draw our first one. This is where I just want to mention the term hydrocarbon at this point as well. So alkanes are a type of what's called a hydrocarbon. Hydrocarbon. By the way, this comes up every year on GCSE papers, pretty much every year. Hydrocarbon. A compound made from carbon and hydrogen only. And you have to say the word only. Only, underline it. Yeah. A hydrocarbon, a compound. So let's have a look at an example. Methane. Gotta love methane. So this is a hydrocarbon. Let's just quickly do it's nice to have an extension on this. So this one, we know that methane is a hydrocarbon. Yes. But this one, let's have a look at this one. This is methanol. Yeah, methanol. This is not a hydrocarbon. No. Our survey said. The reason being is it contains oxygen as well. So it is not considered a hydrocarbon. Just to point out. Put that in a bubble. There we go. Next. So what we now need to do is pick up some naming rules. So this one here is methane. This is methane. So how am I doing this? So what I'm now realizing is step number one in the naming system. So I'm going to change my color for this. Please do the same. I'm going to do it in green. IUPAC, step one. Step one. Longest carbon chain. Longest carbon chain. So if it is 1 carbon long, I'm not going to add anything onto that. I'm just going to leave them blank, because what this now means is 1 carbon means meth. The word meth, yes, that's what I said. So all the people going, oh, Mr. Duncan said meth. So meth tells me 1 carbon. And so if someone goes and buys a methamphetamine, it means it has a 1 carbon branch somewhere, just to let you know. But the word meth, yeah, means 1 carbon in a chain. Yeah, 1 carbon. So what does 2 carbons mean? So if I have 2 carbons in a chain, then that will become F. Yeah, this is eth. I actually prefer eth. Yeah, ethane, eth. 2 carbons. Next, 3 carbons. What does 3 carbons mean? So 3 carbons has a name system, and that is prop. Prop, ... 3 carbons in a chain. Next, 1, 2, 3, 4. Yes, I've put a bend in it. It doesn't matter. Yeah, that is still a chain. The fact that it's kinked doesn't matter. These molecules are actually not straight in reality. If you're actually wondering the real shape of them, they look more like this. Yeah, they're actually kinky. That's right. That's what I said. Yeah. There we go. So this is 4 carbons in a chain. 1, 2, 3, 4. 4 carbons in a chain is bute. It's a bute. Yeah, it's a butt. Yeah, it's a 4-carbon butt. It's really long butt. Oh, sorry, such a dad. Even though I'm not a dad. 4 carbons in a chain. Yeah, now just to show, I just want to show you this bendy thing again. Like, this is still 4 carbons in a row. That is still 4 carbons, because look, I can draw a straight line between them. Yeah? Let me show you what 6 would look like. Like, I could do 6 like this if I wanted. There you go. 6 in a row. That's still 6 in a row, because I can draw a straight line without taking my pen off the paper. If I gave you this one, if I gave you this, now the longest chain is 3 because I can't go back and get to that guy. So the longest chain there is 3. Just explaining, giving some examples. You should include those examples in your notes as well, by the way. Screenshot it, add it in. Yeah, so we've got 4, which is bute. So can I just point out, so this is meth, eth, prop, bute. The first 4 letters are MEPB. So now you can do anything you like here. So the rhyme that I use is Mary eats peanut butter. That's what I put. Yeah. Mary eats peanut butter. Yeah. So MEPB, meth, eth, prop, bute. Because the reason being is the first 4 are the only ones you really need to learn, because the rest of them are really easy. 5 carbons in a row is pent. This now becomes a whole lot easier. Yeah, this is pent. 5 carbons in a row. And this is now dropping into maths. Pent, pentagon, 5-sided shape. Pentane, 5 carbons, all carbon-carbon single bonds. Pent, what does 6 look like? I bet somebody can guess. Guys, what would 6 be? Anyone like to guess what 6 would be, please, on the chat? I'm going to draw out my next one whilst you guys are going to name it for me. Just think of maths. 6, 7. I wonder who knows what 7 would be. You guys have to go up to 10 at GCSE. 8. Wonder who would know what 8 is. It's an easy one. 8. I'm not adding my people on, guys, because I'm just expecting them all to be hydrogens, really, but we don't know. Hex. Well done. 6 is hex. Thank you very much, Masaru. Thank you very much, Zina. Hex. Hexane. Well done, Owen. Well done, Zina. Hept. Hept. 8. Oct. Well done. Octane. Well done, Owen. 9. Is anyone going to tell me what 9 is? I'm trying to draw these out. It's a nightmare. 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. 9. I'm making them smaller. It's nice often if you draw them all the same size, they get large and you realize, oh, the longer one's going to... Non, well done. Nonane, well done. A nonagon. Maths, nonagon. Oh, stupid maths. Oh, 10. Does anyone know what 10 is? I'm trying to count them as I'm drawing them whilst talking. It's a nightmare. 5, 6, 7, 8, 9, 10. Here we go, here we go. There we go. What's 10 going to be? And then it stops there at GCSE, you're done. Up to 10. 10 is deck. Well done, Zina. Deck. Decane. So you have to learn these guys. In reality, though, all you really need to do is learn the first 4. Because the first 4 are the only ones that are tricky, and they're the ones, of course, that always get asked. Because no one ever remembers what they're called. They remember 5 onwards, but they don't remember the first 4. Please, please learn them. Meth, eth, prop, bute. Meth, eth, prop, bute. Meth, eth, prop, bute. Mary eats peanut butter. Mary eats peanut butter. Meth, eth, prop, bute. Meth, eth, prop, bute. Sorry, was that a bit excessive? I think it might have been a bit excessive. Anyway, so nice to know. You've got to know those guys. There is step number 1 in your IUPAC naming system. Being able to spot the longest chain. Guys, I'm actually going to leave you there today. We've covered an awful lot, and we've finally started to build our molecules. We're in these latitude learning objectives, and we're going to be working on these for the next 4, 5, or 6 lessons. So don't worry, as we go through this, you'll slowly pick up more and more rules, and at the end of it, we will come up with a summary set of rules of how to name organics all the way through. So guys, I'm going to leave you be there for today. It has been an absolute pleasure. Really enjoyed myself. Stop sharing screen. There we go. Oh, everyone check out my Mandalorian. Sorry, yeah, my Boba Fett helmet. Loving it. I'll switch back to my front face, get rid of my screen, and bring back myself. You looking at my forehead. Sorry that you look at my forehead most of the time. It's only because every now and again I need to do some dancing. That's all it really is. I'm like, damn, can I do some dancing in? That's all. I've only got 11 people watching. It's not half my class have disappeared. Anyway, guys, have an amazing rest of your day, and I'll see you all very soon. See you next lesson, guys. See you tomorrow.